Hey everyone, geophysicist Stefan Burns here. Boom shakalaka. We have a huge coronal mass ejection quickly inbound to the Earth. Now we currently have a long duration, high intensity solar flare occurring on the sun right now from sunspot group 4100. Check out that plasma shockwave and launched nearly from Earth center and direct, which would be right here. Certainly in the Earth bullseye strike zone. This is headed directly our way, and in fact there was another coronal mass ejection that was launched earlier in the day also towards Earth, though it was not as intense and it was less of a direct shot. So we have two plasma shock waves that are racing towards Earth right now at this moment in time. The velocity on this second one is quite high, and so it looks like we have about 2 to 3 days before impact, and this is very likely to trigger a very significant solar storm impact and therefore a very significant geomagnetic storm. This could be a G3 storm, a strong geomagnetic storm, even a G4 storm, which would be severe, potentially a G5 storm, which is extreme. All those I would say are on the table for just this coronal mass ejection impact here, and this sunspot group is still flaring. It's starting to taper down right now, but this is a long duration solar flare, and as we've seen before with the sun and in solar cycle 25, often when we get these long duration flares, we actually get a whole bunch of them. And so we could be at the very beginning of a sequence of solar flares launched from sunspot group 4100 over the next couple days. And so even though we already know that we have two coronal mass ejections inbound at this moment in time, as it relates to what's going to happen over the next week, how that's going to unfold, that is still a very big mystery. Here we have our CCOR coronagraph view for the past 24 hours, and we can see both of these plasma shock waves. These are known as coronal mass ejections. There's the first one. We see that headed out. Look at that second one. That is a full halo coronal mass ejection, whereas the first one only has a slightly Earth-directed component. We see most of it pushed out there to the east solar coordinate system, though there is that shot headed towards Earth indirectly to some degree. We'll look at the specific imagery of the sun that shows that shockwave sweep towards the Earth a little bit, but the star of the show is this second coronal mass ejection. Look at the velocity on this. Perfect direct shot towards us, extremely high velocity. So 2 to 3 days is my estimate. We do not have any space weather models for this because this is happening right now as I'm recording it. The flare is still active. Let's go straight to the X-ray flux. Here we have our X-ray flux for the past 24 hours, and these sort of explosions on the sun, known as solar flares, release a lot of light energy, specifically in the X-ray part of the light spectrum, which is very highly vibrational, just below gamma rays in their intensity. So their frequency is very, very high. They ionize things very quickly. When they hit the ionosphere, these X-rays from these solar flares, they cause the uppermost part of Earth's atmosphere to ionize, generate more plasma, and that creates radio blackouts. So let us not forget that now with these three solar flares, we've had radio blackouts across the globe. 2 R1 radio blackouts, they're fairly brief, and now a long duration R2 to R1 radio blackout. We can see how long duration this solar flare is here, still active at this moment in time. The peak intensity was an 8.2 M-class flare. This one right there is a 1.6, and then this first one here is a 3.4. And so we've had significant solar flare activity today causing radio disturbances around the globe. And now we have this long duration solar flare that has launched a huge coronal mass ejection our way. Let's check out that first shockwave though that was sent towards Earth. And here we have our 131 angstrom imagery of the sun to see that first coronal mass ejection that was launched our way earlier in the day. Check out that push of energy going out from sunspot group 4100. That was triggered by that 3.4 M-class flare. So a significant solar flare, and that was the first one of the day. We also then had that 1.6, and of course that long duration 8.2, which by the way could ramp up again. But check out the push of energy on that. So you'll notice that most of the shockwave is going like this, but you will also see that sunspot group 4100 is above the ecliptic plane, which is the Sun-Earth plane. So you want to hit the ecliptic plane if it's going to hit the Earth. But also watch how we get a push out this direction from the shockwave. Give that a watch. See how that kind of spreads out like this? That is showing that while it showed up on the chronograph going mostly to the east solar coordinate system, we are going to have some sort of impact from that. And this shockwave certainly is not as fast as the second one. So it's almost certain that whatever plasma was sent our way from this first coronal mass ejection, which is quite a bit smaller but still significant, that is going to get swept up by the second one, and they are going to pancake together and form a much more dense and compact region of plasma at the forefront of this coronal mass ejection shockwave, and that is going to make this solar storm impact that we have in 2 to 3 days stronger than it would have been otherwise. And so I think we're going to have a very significant solar storm impact from this. The only thing that would stop that from being the case is we have a magnetic field configuration that does not connect nicely to Earth. We've seen that in the past. For example, 1972, we had a massive solar storm hit the Earth, but it was mostly a northward configuration for the magnetic field, and most of it brushed off the planet, though there were some interesting effects that occurred around the globe as a result of that significant solar storm impact. But this is a totally different beast. We will have to wait and see how it interacts with us. And we're also going to have to wait and see whether we get more of these sort of solar flares and coronal mass ejections in the days ahead. If you'd like to stay informed, then please subscribe. And a super important modifying factor on all this is the fact that we just got out of a G3 minus geomagnetic storm, which is a strong geomagnetic storm. The scale rating goes from 1 to 5. Number 3 is strong, 4 is severe, 5 is extreme. As you go up in the scale rating for a geomagnetic storm, you're more and more likely to have technological problems. For example, issues with satellites, GPS, that's a really big one, potential power grid failures. There's also a variety of biophysical effects and overall health and wellness symptoms that can result of very strong solar activity and geomagnetic fluctuations. So here we have our current HP60 index going all the way back to around May 22nd, and we see that our conditions were basically calm and quiet until we had a little bit of activity at the forefront. This was a high-speed stream impact from a coronal hole, though it wasn't that large, and then the big one followed up behind it another high-speed stream impact that quickly rose our HP60 index to about 7 right there. So we had that G3 minus print, and then it settled down to a G2 storm and then a G1 storm. So this has been a long duration geomagnetic storm, meaning that Earth's magnetic field is already undergoing these changes in field strength. The plasmasphere is already being reorganized as a result of all this. There's these downstream energetic and geophysical changes that take place during and after a geomagnetic storm. And with this solar shockwave combo coming to Earth in probably just about 2 or 3 days maximum, we are still going to be within all these energy reorganizations. The ionosphere is extra charged up as a result because this sort of solar storm impact causes the plasmasphere to precipitate down into the ionosphere, creates more plasma, charges up more, and the strength of a geomagnetic storm in many ways is determined by the ionosphere. You have more plasma up there, then you have these stronger electric currents, and it's those electric currents in the ionosphere that generate the magnetic field swings that we register at the surface of the Earth, and of course also going out the opposite direction. Earth's magnetic field is fairly static. It's these electric currents that are generating the swings on top of that fairly static magnetic shield. And so this is going to amplify the effects of this solar storm impact that we have coming in, and time will tell how significant that change is, but that is definitely a +1 or a +2 factor to add to this. Another important modifying factor on the space weather at this moment in time is the fact that we have a Mercury cazimi, which is active. Here is Mercury showing up on our C2 coronagraphy. We see it there just having performed its cazimi, that is its superior conjunction with the sun. Right now it's on the other side of the sun. And so right at that moment in time where it's here, it's exactly opposite the Earth on the other side. And I put out an update on May 24th speaking about the critical planetary geometry that we had from May 29th to the 30th, and how it was likely to result in some magnetic storming that was going to be stronger than expected. Well, we had a G3 minus geomagnetic storm, but just because we had the storm doesn't mean that this energetic influence is not still active. And so now we have these significant solar flares that are occurring. Mercury on the far side of the sun in alignment with the Earth, and that big sunspot group right there on the Earth facing side in that alignment, and boom, we get a long duration 8.2 M-class flare and a huge coronal mass ejection launched our way at high velocity. And so planetary geometry seems to be a very valid method for forecasting space weather going further out. The next long-range forecast is for June 21st. I talked about that in my last video. I'll continue to talk about that because we have a grand trine, a grand cross, and also a kite configuration. 3 different critical geometries stacked on top of one another. That's right around the Jupiter cazimi. So keep that in mind, June 21st. But we have this big solar storm impact coming up first, but this in general is another one of these +1 modifiers you could say. I think we have a very significant solar storm impact coming in. And we can see radio blackouts with our D-region absorption model. Boom, there is one over North America. That is from that 3.4 M-class flare. And then we also had a slightly weaker but still significant R1 radiation storm centered more over Hawaii in the Pacific Ocean there. Then we had a bit of a brief period of time where there wasn't any significant radio blackouts as a result of these solar flares because, well, there weren't really any solar flares. But then that 8.2 M-class flare comes in right there. Look how strong that is. And again, look how long duration that is. It is still in effect right now as I'm recording this video. These are the sort of radio disturbances that have a big effect on a lot of different industries. And so this is active right now. If sunspot group 4100 continues to flare, we could see more of these radio disturbances. And these sort of powerful radio blackouts is exactly what this critical planetary geometry forecasting method was devised for by J.H. Nelson in the 1940s, 50s, and 60s. He worked for RCA Communication, which was concerned about radio communication around the globe. And so he correlated what's happening with the sun in terms of sunspots and solar activity with planetary geometry and then radio disturbances to come up with his forecasting method, which saw great success during that time frame and in general was kind of forgotten about afterwards as we then entered into the space age. And while I'm bringing it back, we see here this long duration 8.2 M-class flare causing a significant long duration R2 radio blackout over the Pacific and Southeast Asia, and that is within that critical planetary geometry time frame of May 29th to 30th. Of course, you can add a couple days on each side as well because that is still active for a while. That configuration stays active for probably about 3 to 4 days. Again, the next one coming up June 21st. And here we have our past 48 hours of intensitygram data for the Earth-facing side of the sun, which allows us to see sunspots. And you'll notice 4100 there at the very end of this video is starting to grow significantly and also change in its shape and size. And so it's this new flux pushing out from deeper within the sun that's causing this sunspot to destabilize. You get these magnetic reconnections and you get these really strong electric fields to develop, which can cause the rapid acceleration of these sort of particles and plasma in general, launch that coronal mass ejection out into interplanetary space. And well, we just happen to be right at Earth center because we're looking at this Earth center direct. And so you get a sunspot right in this zone and it launches something big that's going to head our way, almost certainly. You will also notice a new sunspot group following right behind, developing just in the past 24 hours and doing so quite quickly. That is sunspot group 4104. And so that is also looking pretty spicy. It did give us a flare already, a 1.6 M-class flare. So it was created and then gave us a significant solar flare pretty quickly, an M-class flare, the second strongest category of solar flare. We also have sunspot group 4099 down there, and it has been active on and off for the past few days, but as of today really has not done much, though it is even closer to Earth strike zone right now at this moment in time. And we're getting new growth there to the west of sunspot group 4100. So a big push of solar flux in general on this part of the sun, all that moving through that Earth center transit zone at this moment in time. I think we have more than just this long duration 8.2 M-class flare that's occurring right now ahead of us. I think we potentially have other solar flares and potentially other coronal mass ejections headed our way as well. So this could be a very, very, very dynamic week ahead of us. We had the lowest sunspot count in a long time for May. That number is going to come in at under 100, a nearly 50% drop from the 6-month average that we've been having of about 150 sunspots for the past 6-7 months. When you have these really big volatile swings in these sort of parameters on the sun, like sunspots or solar flux, that's usually a sign that you're going to have a swing in the other direction. So a big drop in sunspots, now we're seeing a big increase in sunspots back up, and that is why things are so volatile right now. And looking at our chronograph one more time, we see these two plasma shock waves. There's the first one. Check out again the velocity on the second one, the density on it, and exactly dead on towards Earth. So we'll have some space weather models over the next 24 hours or so. I will keep you up to date every step of the way. Again, I've been your host, Stefan Burns. Thank you so much for watching. What we cover on this channel is what's happening with the Earth energetically. So we examine what's happening with geologic events, geophysical energies. We also just had a magnitude 6.2 earthquake south of Africa near Antarctica in the past 24 hours. That's a pretty big one. We then examine solar activity, space weather, planetary resonances, planetary geometry, even cosmic factors. I bring all that together, present videos almost daily as to what's happening here energetically. If you like the sound of that, then please subscribe. Wishing all of you well. Make sure you do your earthing and your grounding. Get outside, get grounded, get calm, centered, cool, and collected now at this moment in time, because very, very soon we're going to have a significant geomagnetic storm as a result of this combined solar storm impact, and potentially more to follow after just this first really significant shockwave right there. Wishing all of you well, love and light, and I'll see you all in the next video.